Welcome. My name is Chase Robinson. I'm the Provost of the Graduate Center, and I'd like to begin today's very interesting events by making two sets of very brief comments. First, a very short introduction to who we are at the Graduate Center, so you know what kind of place you're going to be spending your day, and then very brief introductions to what is in store for you, and indeed what is in store for you is, I think, a very, very interesting set of presentations. Now, with nearly 4,500 students and 34 doctoral programs, about 35 research centers and institutes, the Graduate Center of New York City University brings together graduate education, advanced research, and public programming here in our wonderful Midtown location. We educate leading scholars of tomorrow. We advance scholarship in and across disciplines ranging from anthropology to urban education. With a distinguished and a diverse faculty of some 1,900, we're one of the nation's largest doctoral granting institutions in the country in the humanities and social sciences, usually second or third, second sometimes to Berkeley or UCLA or Texas. We are committed to advancing knowledge and fostering an academic environment in which scholarship seeks the broader and deeper understanding that's possible when the barriers of academic disciplines are lifted. That is a kind of statement of principle, and in fact, I think what we have here today is a good example. It is a great pleasure for me to welcome you to the Graduate Center. It's a great pleasure for me to begin today's events, this very special event, analyzing New York City's response to Superstorm Sandy, how well prepared the city is for the next challenge of this magnitude. On three different panels today, you'll hear climate scientists, disaster preparedness and emergency response specialists, and public health analysts and experts from the City University of New York, from the public and nonprofit sectors, and from city government, all of whom will be discussing the lessons learned from the devastation caused by Superstorm Sandy and its aftermath. Now, many people helped to organize today's events, but I'm especially keen to acknowledge Herb Berman, a former city council member from Brooklyn, chair of the council's finance committee, and special assistant to President Kelly. Without Herb, today's events would not have taken place. So without any further ado, I'd like to now turn the stage over to Dr. William Fritz, interim president of the College of Staten Island and also noted geologist, who will moderate and participate in today's keynote panel on science, climate, and storm prediction. Bill.
Okay, good morning. Just testing to be sure that our mics are working okay. I think we have a really great panel this morning to begin exploring the theme of Are We Ready for the Next One? We have with us Dr. William Solecki, who is a professor of geography and director of the CUNY Institute for Sustainable Cities, Hunter College, and co-chair of the Mayor's Panel on Climate Change. So, thank you. Also, Frank Buonaiuto, who is Associate Professor of Geography and Director of the Laboratory for Marine and Atmospheric Research at Hunter College in CUNY. And Dr. Allan Frei, Professor and Chair of the Department of Geography and Deputy Director of the CUNY Institute for Sustainable Cities at Hunter College. So, thank you. Welcome, 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 panelists. And I'm going to work with the technology here to get the... Okay, we're going to start off. I'm going to make a few introductory remarks, then I'm going to turn it over in turn to each of the panelists, and we'll try to reserve time for questions so that this can actually turn into a conversation near the end of the setting. I like to see things from the 50,000 foot viewpoint, so I'm going to try to set the stage with some maybe bigger picture introductory remarks. One of the things that I want to emphasize today that I think is going to come across in the theme of the three panelists is the power of an interdisciplinary approach. I think to solve issues like are we ready for the next one, We really need to have a team of business leaders, social scientists, humanists, the widest possible perspective. As a scientist, I've been involved in a number of disaster initiatives throughout my career, and what I find is commonly the theme is scientists make predictions of what may happen, and whether it's flooding or earthquakes or volcanic eruptions, and no one listens. And I think sometimes no one listens because we haven't used that interdisciplinary term. As scientists, we think we're communicating the message, but for that message to be communicated, it has to be communicated in a way that people can hear that message. So my real message this morning is Irene was a wake-up call a year and a half ago. Sandy was even more of a wake-up call for the New York metropolitan area. For several years, I've been working using the CUNY Interdisciplinary High Performance Computing Center, which is housed at the College of Staten Island. And we've taken our data. A lot of people have data on seafloor conditions from North Carolina south, but there hadn't been a lot of attention paid to North Carolina north. And we've merged our data set with the Renzi Computer Institute at University of North Carolina, and have been looking at storm surge modeling following Irene, because what we felt is that people were lulled into a false sense of security with Irene. Irene was mostly a rain event, and so basements flooded. There was a bit of wind, but at least on Staten Island, many residents sort of breathed a sigh of relief and said, well, we survived a hurricane. What's the big deal about a hurricane? And so we felt that with a little bit different eye track, Irene could have been a very, very different event. And so we started using modeling to see what a surge would have looked like. And, 5 months before Hurricane Sandy, we wrote that most New Yorkers don't think of New York being in the hurricane belt, but we really should consider ourselves as being in the hurricane belt. And so we were modeling with a 12-foot surge. It turned out that Sandy had about a 14-foot surge, but the modeling showed that it could get fairly close to what the real conditions would look like. Now, as a result of Sandy, I think most New Yorkers now understand that we are in fact in the hurricane belt, even though we don't get hit as often as some of the cities further to the south. We are in a particular vulnerable area of the East Coast, and we're going to get hit again. If we look at historical records, we have been impacted many times. We had modeled a 12-foot surge. Sandy was probably somewhere in the neighborhood of a 14-foot surge. We could model a 20-foot surge. If you went to a Category 5 hurricane, you could probably get to something close to 30 feet. The likelihood is much lower, but certainly there's a possibility of higher. We know that in 1932 there was a hurricane of unknown strength, at least on Staten Island, from looking at newspaper photographs, had at least a 15-foot surge. And in 1938, the storm that is often called the Long Island Express on Staten Island probably had a 20-foot surge, again from looking at newspaper photographs taken at the time. Both of those events would have been considerably stronger than Sandy. I think the reason that many residents even on Staten Island, don't remember those events is because the surges rolled across undeveloped marshland. And so a surge going across undeveloped it's no one notices. The problem is is we've hardscaped our sponges. We've developed those marshes since then. Each storm is different. The combination of the eye track, the surges. I'm sure that we'll hear that from our panelists here in a few minutes. This isn't advancing, so I'm just going to reach over here to. For some reason, the keyboard, maybe if we get some help with the technology, the keyboard doesn't seem to be advancing the slide. I guess my other point is that I think sea level, we need to think of a higher sea level as the new normal for New York. Sea level has been rising about a foot a century for the past 5,000 years. Many climate scientists think that could increase to 2 to 5 feet a century in the upcoming years. you know, just think about it. When Henry Hudson encountered Manhattan in the early 1600s, sea level, worldwide sea level, was probably 4 feet lower than what it is today. You know, the tunnels wouldn't have flooded from a Sandy type event if we had had a static sea level. And of course, with the possibility of that rise in sea level really increasing, that's been sort of masked, especially in Manhattan, because we've been building up and out faster than sea level has been coming up. And so many people think, well, I don't notice a rising sea level because we've been building out, but that's not sustainable. We can only build seaward in the face of a rising sea level before long before things catch up with us. Okay, it's working now. If you look at this slide, I think it shows why we should be so particularly concerned in the New York area, because the modeling that we've done would suggest that we sit at probably the most vulnerable point in the entire eastern seaboard. Not only are we most vulnerable, we're clearly the highest populated area of the eastern seaboard. And so what happens when the storm surge hits, and the storm surge is a combination of a low pressure bulge, wind pushes water on top of that bulge, the bulge can rise on a rising tide, but the factor that often isn't taken into account is how the shape of the shoreline can produce high pressure water or a high pressure bulge. And so we have nearly a right angle between the east-west southern shore of Long Island, the north-south shore of Jersey, a rapidly shallowing seafloor as you come into New York Harbor. And what happens, it produces what I like to think of as a high pressure. If you're, you know, pushing a wave down the bathtub and it shoots up the far end because of the geometry of the coastline. And so the coast of Staten Island is sitting right at that area that receives, you know, the brunt of the surge. And then the water pushes up New York Harbor, where it's trapped by water that's being driven along Long Island Sound. And so that combination of events, I think, makes the New York Harbor one of the most vulnerable points on the eastern seaboard. And of course, we've hardscaped our sponges. We've taken many of our marshes and coastal dune fields and barrier islands that are often nature's protection and hardscaped them. And so it's really worsened the event. So again, my message is the unique geometry of our coastline, worldwide rising sea level, makes it a particularly vulnerable situation. We're going to be hit again, again on Staten Island. I talked to many residents who even now, following Hurricane Sandy, will say, well, it's been a long time since the last one. We have 100 years to the next one. I think there's still a misunderstanding of how vulnerable we are. It isn't. And so my message is we shouldn't breathe a sigh of release just because we survived Sandy. We really need to prepare for the next one. So I think I'm going to turn it over. I want to hear at this point from some of our other panelists. Let's start off with Allan. Allan, you can speak as an expert on climate change and talk about what the future might hold. I've tried to set the stage, at least from my perspective, that sea level and climate could change in the future, but we really want to hear your
yeah, I have some slides. Can we, should I just go up? So I'm not going to actually talk about all of this, but what I'm going to focus on is the question of Hurricane Sandy and climate change, because that's such a big issue of discussion. I'm not going to talk about the media discourse, which is in the title there. And one of the things about it is that people referred to this hurricane as Frankenstorm, which implies that we've made this monster, right? And that's the question I'm asking. What are some of the physical features that made this such a monster? Let's see. The sea surface temperatures were warmer than average out in the Atlantic Ocean, and that feeds the hurricane. We have a warmer atmosphere than we used to have on average. Warmer atmosphere can hold more water vapor, and water vapor is the energy source for hurricanes. And then, of course, there's more water available for precipitation. There was a high very high storm surge, as we've heard already, due to a confluence of events. Sea level has been rising. It happened at high tide and full moon and the shape of the coast. And it was a very unusual storm track where it was heading towards the northeast and made a sharp left or westward turn towards the coast. And here's my little summary of, is this climate change related? Well, sea surface temperatures are warmer than they used to be on average. So you can make the case that there's some relationship, although the particular, that month had a particular warm sea surface temperatures. That's just an event. That's not necessarily climate change. Warmer atmosphere, yes. Sea level being higher, yes. So a lot of the discussions about extreme, what meteorologists, climatologists call extreme events, droughts, floods, storms, any of these extreme events, is that they're happening in a background context where the physical climate system, the ocean and the atmosphere, are different than they were. And you don't have to forget about what humans have done, that it happens to be true. Things are different than they were 50, 100 years ago. The most interesting question that has come up is this issue of this unusual storm track, because people say, well, that can't be climate change. The unusual storm track was, again, due to an unusual combination of patterns. The warmer than average waters out in the Atlantic Ocean, the what's called an atmospheric trough over eastern North America. And I'll show what that means. Here's a little map showing these areas in green had warmer than average temperatures. This line that I drew, this is an atmospheric circulation chart, which I don't expect most people to be able to read. But this line that I drew in there, that's the jet stream. Okay? And the jet stream has a major effect on where it's warm, where it's cold, and which direction storms take. And this particular shape of the jet stream that we had at the time of Hurricane Sandy is a shape of the is a shape that is conducive to stronger storms, and is a shape that will steer storms that are heading in this direction to take a sharp turn towards the west. And in addition, there is this thing called a blocking high pressure over the North Atlantic, which between this blocking high and this low in the jet stream forces the storm to move in the direction it did. And is this a chance confluence of events, or is it climate change, and is it a harbinger of things to come? And that's actually still a topic of discussion, but here's how complicated the Earth system can get. The theory that that these patterns will happen more frequently under the changing climate is based on what's happening up in the Arctic Ocean, believe it or not. And this picture on the left is a picture looking down at the surface of the Earth from above the North Pole. Here's the North Pole. Here's Greenland, Canada, and here's Siberia, and here's Scandinavia. And this white area is the area, a recent, September 2012, this white area was covered with sea ice. This purple line shows the area that is the median extent of the sea ice for the last 30 years. In other words, the last few years, and I'm sure everyone's heard about this, in common vernacular, they say the ice caps are melting or whatever. The area covered in sea ice is decreasing. And that's related to the fact that the northernmost parts of the climate, the Arctic region, is warming much more than the rest of the planet. As a result of that, the theory is that you will get more of those patterns that we talked about, because the strength and the pattern that the jet stream makes depend on the temperature difference between the Arctic and the tropical regions. And as that temperature difference decreases, because the Arctic's getting warmer faster than the tropics, you would expect, or at least according to some theoretical models, expect to get more of these wavy patterns with blocking highs, these wavy patterns that don't move very fast. And so this is not a crackpot theory. This is real possibility that these sorts of patterns, that we're seeing more of them already, and that this is related to the warming in the Arctic Ocean. And as a result, you get these sorts of hurricane tracks. And that's a possibility. And so, put another way, is the climate system on steroids? That's the analogy that people use, and I think that's probably where I'll end, is basically that, think of the baseball analogy is a very popular one. If a slugger is on steroids, you cannot attribute any one home run to the steroids, right? Because they've been hitting home runs for years, right? But if they start taking steroids and they start hitting 20 more home runs a year than they used to, at some point, people start believing that the steroids are increasing the numbers of home runs they're hitting. And that's the analogy we're using here. We're setting up the boundaries of the climate system to make certain types of patterns more common. Yeah, so I think I'll, that was my comments. I want to keep it short.
Get your slide ready. Oh, no, thank you, Allan. I think that, you know, as we've seen from the historical record, even though we call it an unusual storm track, we know that that track has happened before, even though it's an unusual, not every hurricane follows that track, but what you're suggesting is that type of track could increase, and not only could the severity of the storm increase, but that particular track could be more frequent in the future.
It's one of the possibilities, yeah.
Okay, I want to turn it over, thank you very much for those comments. I want to turn it over to Frank. Dr. Buonaiuto studies storm surges and storm surge damage, and we want to hear his perspective on storm surge damage and how this fits into the story of how we should be preparing for the future.
Right, I thought it was important moving forward to try and put this storm surge, this event in context, or what we believe is what this event represents. Now, I'll get into the detail of it a little more as we move forward, but a couple of things to just draw your attention to. This is some of the background information that we know of Hurricane Sandy, but when we're dealing with what the observed water levels were, often we refer to them as still water levels. So we're going to try and tease out the difference a little bit between what we call storm surge and what we call still water level. Storm surge is really the additional water that's put there up against the coast related to the storm. It can come, as Professor Frisk said, from the bulge of water that's coming in, the low pressure system, winds piling the water up against the coast. The other thing that's often ignored at this point in time is the effects of waves. Waves coming in can pile additional water up against the coast, and a lot of our storm surge modeling efforts do not account for wave setup. To give you an idea, Hurricane Sandy had peak waves of about 32.5 feet right at the entrance to New York Harbor. Wave setup up against the coast can be upwards of about 20% of your breaking wave height. So in the case of Hurricane Sandy, you may have had an additional 3, 4 feet, 5 feet of setup up against the coast. Now thinking about this, the waves persisted for several days, not at that 30-foot mark, but for 3, 4 days following Hurricane Sandy, you had waves that were in excess of 12, 15 feet, continuing to propagate up against the coast, and in part help hold all of that water up against there and flood for several tidal cycles. So it's one of the things we have to keep in mind. In terms of still water level, the still water level is what's actually observed. What did we see at the battery? That's the combination of the tide, the storm surge, the wave-driven setup. If there's any freshwater flooding that's occurring as well, if it's a heavy rainfall event, that will all influence still water level. What we had seen at the battery is about 13.8 feet above mean lower low water. That's your still water level. So that is fairly high. The actual surge piece of that, the part that we're attributing to the storm, is about 8.2 feet. 8.2 feet of surge on top of an astronomical high tide with wave setup, and we see this 13, almost 14 feet above mean lower low water. Now, to try and put this a little bit in context, often you'll hear scientists talk about return periods. What's the return period of this still water event? Does it represent an event we're going to see every 100 years? Or does it have that sort of 1% chance any given year that we see? They'll call it the 100-year event. Oh, Sandy, well, when we look at Hurricane Sandy, where does that fall in terms of return periods? Now, the thing we have to keep in mind when we look at return periods, when we construct return periods, we look at water level gauges. So how long do we have data for? 100 years, 150 years, depending on our tidal record that we have. We're looking at all these various water levels, constructing our return period curves, and then we plot Hurricane Sandy on there to see where it falls in. In some locations where we do not have water level gauges, we'll augment that with modeling efforts. Storm surge models will try and take some historic events, try and modify that with different storm tracks to add what are other combinations and possibilities that might occur, and sort of construct these curves that we believe, well, how often will we see a water level of 13.8 feet at the battery? When we plot Sandy, which is up on the, let's see, I think I have a pointer here. Nope, no pointer. So you can see Sandy's plotted on the upper, oh, the red button, nice. Technologically challenged. So Sandy's plotted up here. When we look at Sandy, the still water level plots at about a 699-year event. That's what we believe it was, the still water level. The surge event, just the surge, is a little less. The storm surge from Sandy is about a 313-year event. So we're kind of saying, well, roughly every 300 years we'll see something like Sandy. But that's now based on our historical record and the modeling effort that we've done. As the climate changes, as sea level continues to rise, these effects, we might see more Sandy-like events. What we are seeing already, and Dr. Frisk mentioned it before, when you think about Hurricane Irene, we're already seeing a shift on the lower end events. These events that we consider somewhere down in here, these 5 and 10-year events, a storm that we would get every 5 or 10 years, we are already seeing an increase. As a matter of fact, FEMA looking at the data, FEMA basically said, well, New York has seen a 5-year event every year for the last 3 years. So when you start to think about this, we're already seeing a shift on these lower end events. Does it mean we'll see a shift on the higher end events? That is a pretty big question. When we look at some of our other locations, so now this is just at the battery. When we start moving around the coastline, where do we sort of put Hurricane Sandy in context of different locations? These are just some of them that I picked out. Coney Island's in here. You can see is around a 275-year return period. Rockaway, 250. Parts of Jamaica Bay considered a 700-year event. I'm not saying that it actually is a 700-year event. Just based on our modeling effort, the data that we've had in the past, what Sandy actually produced in these different locations, this is sort of where we would put it in context. Now, as we know that as we move further out east, we did see less damage. If you get all the way out to Montauk Point and you look at the return period out at Montauk Point, you wind up that Sandy is about an 80-year still water level event. And we see this in the damage as well. Looking at the whole coastline, there was far less damage as you were further out east, and the damage was concentrated in the New York Bight region. So and this is laid in the background here is FEMA's high water marks that they've plotted up. And so we see this as we make our way along here, that the damage was concentrated in this region. And as Dr. Fisk mentioned, it has a lot to do with the orientation of the coastline. It has a lot to do with the width of your continental shelf as that long surge, that long wave, we would call it a long wave. As the long wave comes in, it shoals, it can grow a little more, as well as being funneled into the harbor. So it's definitely set itself up to increase the damage moving from east to west. The other thing to keep in mind here, when we look at our storm surge models, we do have a few forecast storm surge models. You have NOAA's forecast model, Stony Brook runs a system, as well as Stevens Institute of Technology. Those three forecast systems underpredicted the storm surge by at least 3 feet. Now I know from background information, Stony Brook and Stevens do not include wave setup, so that could be some of the error that those systems had, not including wave-driven setup, additional water piling up against the coast. The other issue, those of you who may have been watching this, if you did not lose power, Stony Brook's system went down very early. So even trying to watch this go up, you had the early forecast, but then they went down and sort of the lead up, the last 6 to 10 hours towards the actual impact of the storm, that system went down. So we did run into some of these technical errors. Now, in terms of some of the damage that was seen, some of the other issues I'd like to at least highlight in this panel discussion, a lot of us saw the pictures, the damage that took place. Some of us witnessed this firsthand as our homes were destroyed. We know there were fires in the Rockaways. We saw lots of overwash and flooding. Not all of the impacts of Hurricane Sandy and the damage that was caused are a bad thing. So this, sort of the other thing we have to think about, we know there's a lot of issues that are facing our barrier islands, especially in the face of climate change and rising sea level. Will our barrier island systems, will our beaches be able to keep up with higher sea levels? Well, some of the natural processes that help a barrier island system maintain its elevation is overwash processes, such things that we saw during Hurricane Sandy, where our dune system was pretty much blown away and pushed into the interior of the barrier island and into the bay, creating more wetland habitat. We opened up 3 breaches on our barrier island system, which I have labeled in here. 2 of the breaches were in Suffolk County lands, Cupsog County Park and Smith Point County Park. One is in federal land, which is the old Inlet Wilderness Breach. Now, this helps improve water quality. Not only did you push sand into the bay, potentially fostering wetland development, and most of us are aware that we're losing wetlands at a rapid rate, but at the same time, you're improving water quality in some of these locations. 2 of these breaches have been closed. So this is just aerial photographs of the breaches, if those of you who did not get a chance to see them. Breach 1 is the wilderness area, breach 2 is Smith Point County Park, and breach 3 was Cupsog County Park, and that's just a ground photo of Cupsog. The 2 county breaches were closed immediately as part of a breach contingency plan that was already in place, anticipating that we could have an opening during a major storm on our barrier island system. There was already a plan in place to close the breaches in certain locations. The county chose to close their breaches, and they were sealed off right away. Literally within a week or 2, people were already mobilizing to close these breaches. There is one breach that is still open. The breach that is open right now is Old Inlet, which is the eastern end of Great South Bay, and it is scheduled to be closed after piping plover season, which is after the summer. So it will remain open for the summer. For those of you who like to fish in Great South Bay, you might chance navigating the inlet, but there is actually some public support to leave the inlet open. It's improving water quality in Great South Bay, in an area of the bay that typically is dominated by freshwater input and wind-driven circulation that is, for the most part, very poor quality. So now there's this opportunity that arose from Hurricane Sandy to actually improve a little bit of our Great South Bay water quality, and there is a public interest to keep it open. So some of the things that come to light when we're thinking about Sandy, and I'm sure Bill will touch on this a little bit, there were some good points that came out, such as supplying sand into the bay, creating potential habitat for wetland growth, improving water quality. And so now we're faced with this issue, well, what do we do in a situation like this? Do we allow the barrier system to behave a little more naturally? Do we come in, close a breach that's, in this case, at Old Inlet? How do we maintain our coastline? How do we maintain our barrier island system? Which is an issue that we have to grapple with. And I think the last thing I leave you with is some other overwash processes. And we're trying to document this now, going through some of the LiDAR data and the aerial photographs to see how much actual overwash took place, what the volume of material that has been pushed into the barrier island, and sort of quantify this process. As of right now, we've looked at Fire Island. We have about 14 sites. We know at least 2 square miles of overwash occurred on Fire Island. And what you're looking at here are actually further areas further east, some of the different overwash processes. Here's areas along Dune Road. Now you're moving down towards Shinnecock Inlet here, Tiana Beach. But a massive amount of sediment was pushed in, deposited, elevates the barrier island, pushes some of the sediment into the bay for wetland habitat, which is not necessarily a bad thing. Where we stand now on this is emergency repairs, trying to build our dune system, which at this point is broken. We do not have a continuous dune system anymore, and so now we're going back trying to rebuild these dune systems, but at the same time we have to think if that's really the best, is that really the best method? And so that's where I leave this, and we'll pass it off to Bill.
Okay, thank you, Frank. I think that gave us a really good perspective on storm surges. You know, we've heard from climate change, from the processes of storm surge. I want to now turn it over to Bill Solecki, who co-chairs the mayor's panel on climate change, and really get his perspective on city planning with respect to building and recovery, maybe in light of some of the things we've been discussing with the increasing storm surges, increasing changes to climate, and what should we, what can we, what are we doing in terms of city planning?
Great. Thank you. Like my colleagues, we're colleagues in the department, but also as a geographer, you know, geography is about sort of straddling the physical and the social sciences. Most mornings I wake up sort of thinking as a social scientist, although a lot of my work in this context sort of brings to bear my physical science training and looking at science policy interface. So that's really, in large part, some of the work that I'm going to be talking about today in terms of what are some of the ways in which Sandy has changed our understanding about climate risk in the city, and what are some of the early lessons that seem to be emerging from that sort of recognition of the connection between Sandy, climate risk, and climate change. So I'm just going to run through a few slides, and then I think we'll turn it back to Bill, and then sort of open it up for discussion. I think this is already, some of the things I'll mention have been stated in various ways. We knew that the New York metro region was highly vulnerable, and certainly there are a number of studies that have illustrated that, outside of Miami, the New York metro region is one of the more vulnerable parts of the eastern seaboard, and there are lots of factors sort of illustrating that vulnerability or exposure is increasing, particularly with changes in the nature of hurricanes. The current sort of understanding is that we might not get with climate change more hurricanes, but they'll be more likely to be more intense hurricanes. Also, we see increased sea level rise within the region, the mid-Atlantic regions, again for a variety of factors. So the exposure level is certainly going up. And I think one of the things that that Sandy sort of brings forward is a whole set of questions about what does it mean with respect to exposure and vulnerability, and what kinds of responses, what does it mean about disaster risk reduction, climate change adaptation. So there are a number of different sort of questions that sort of come into the picture. And the issue we saw earlier, Frank's sort of illustration of some of the inundation area, that's sort of a zoom in a little bit in lower Brooklyn and some parts of Queens, and then sort of connecting that to some of the work of the New York City Panel on Climate Change, which has tried to sort of illustrate what future sea level rise conditions might look like. And this is some work that was done a couple of years ago, sort of illustrating under a particular scenario what a future sea level rise would look like associated with a 1% or 1 in 100 year flood. So it's that sort of connection between the inundation and what some future climate conditions might look like is part of the question. And I think one of the things that's sort of important to think about when we think about disasters, I mean, historically, humans have always been sort of responding and trying to recover from disasters. Oftentimes, particularly in the 20th century, it was, okay, how do we build it bigger, stronger, to a technological fix, to sort of become resilient, in a structural engineering way to future climate events. And to sort of look back at that historic record and sort of, okay, so try to figure out what is the event of record and how to build higher than that. So for example, the Con Ed facility that blew out in Lower Manhattan and had that resulted in the power failure in Lower Manhattan actually had a storm surge barrier around that facility that went out. And it was actually a foot or more higher, maybe a little bit more than the storm of record, the storm surge of record as was understood at that particular point by the engineers who built that. And of course, in this case, Sandy sort of overtopped that. So there was some structural elements in place, it just wasn't significant enough. So one of the things that sort of is important about Sandy and sort of this whole notion of responding to hazards is that it has started to change the dialogue, and I think Allan's presentation sort of pointed that up as well, where we're not so much looking at historic situations of past events or sort of Hurricane Sandy as a benchmark. What we're also starting to look toward is the future, and the idea that extreme events are sort of embedded in this sort of larger sort of process of climate change. And so as we start to, this idea of recovery and long-term recovery and increased resiliency, the question becomes not only how to respond to the event of today and the events of yesterday, but to sort of as a moving target to understand what the future climate change might mean with respect to future exposure. And that we have to sort of make sure that those lines are intersecting, that we're actually integrating that future understanding into our rebuilding process. So I think that's a pretty profound set of a pretty profound change. And this is sort of counterpoint to Hurricane Katrina, where in general, the rebuilding of the levees in Katrina in and around New Orleans did really not integrate climate change and sea level rise conditions into that rebuilding strategy. And so the question is, in the process of rebuilding that goes along the coast, New Jersey, New York City, and New York State, how much of that climate science is going to be integrated is a critical question. And one of the things, and again, this is sort of some previous sort of work that sort of illustrates some of this notion. And this is, I'm just illustrating sort of worst case scenario and some of the data. This is again published several years back, but looking at how this sort of frequency of events could change over time. So, for example, we see a base flood, condition of a 1 in 100 year event. And this is sort of the classic metric that FEMA and others and insurance companies use as to whether or not you're buying property in a flood zone, et cetera. But if you take into account sea level rise, and this is a rapid ice melt scenario, where we see, instead of the roughly 1 inch per decade that we've seen in the past century, we could see up to 4 inches per decade by the end of by the end of this century. So with that, you have this sort of notion, it's a very simplistic sort of illustration, but as you start to have a vertical rise of water, that same 1% flood or 1 in 100 year flood will have a much more inland or horizontal flood extent. All right? And so flip it around the other way, you could have a smaller event reaching that same spatial extent in the future. And so what this chart is sort of illustrating is a reduction of periodicity. I want to, again, qualify that this is a worst case, derived from a set of models. I'm not saying this is what is going to happen, but it sort of illustrates the power of understanding that we're in a very dynamic climate situation, and we need to sort of take that into account. And so we sort of look at some of the data products that the New York City Panel on Climate Change has produced. This was part of a report that came out a couple of years ago illustrating the notion of this 1% flood zone. So this is the FEMA at that time, 2009, 2010, 1% flood extent. And then these are some of these rapid ice melt scenarios, which is again sort of a higher case sort of scenario, illustrating what the flood extent of that 1% flood might be with this additional sea level. Okay, so again, imagine the vertical rise. So if you're looking down at the battery and you're saying, you know, if you went there in 1900 and you went back in 2000, there'd be, you know, at mean high tide, there'd be about 10 inches or so of additional water. In this context, as you're moving into the future, by the 2080s, there could be a little bit more than 3 feet, actually, sorry, a little bit around 4 feet of water in that same location. So you're going from about 1 inch per decade to about 4 inches per decade. And so with that vertical rise, you're going to get that much sort of greater inland extent of flooding. So again, remember the flooding that took place at, let's say, Water Street in Lower Manhattan. You know, a lot of people went down to the water's edge and sort of saw where the water was coming up at Water Street. So just imagine that you have 4 additional feet of water at that particular location. What you could sort of, you know, imagine in your mind how much further inland that extent of water might go, and with that, you know, obviously increased damages. So one of the notions that the NPCC has been promoting is this notion of flexibility, that there's a certain level of acceptable risk that every society sort of defines with respect to how it wants to govern itself and its properties and its livelihood, and that's sort of illustrated by this sort of wavy line here, and then that there are certain notions as an acceptable risk, how that might change, or how the risk might change over time with a changing climate. And so the idea is how to create conditions, if we do a status quo, that will most likely exceed those acceptable risks at some point in the future. And of course the question then remains, how do we kind of create conditions under which we keep that acceptable, below that acceptable risk line? And one of the sort of measures that oftentimes is included is flexibility. So as we start to rebuild, recognize that we have to build structures that enable us to sort of revise and sort of adjust as the climate science emerges over the next decades and even more as climate change unfolds. So for example, if you want to, let's say you're building a seawall with a certain base with an expectation of a certain height, if you feel that in the future you might have to build that seawall a little higher, then you can make a simple engineering adjustment by making that seawall a little wider to take greater weight, or to sort of physically be able to be built a little higher. Of course, this gets into these really crucial questions of economics. Building that seawall a little wider as a wider base is going to cost more money. So where does the sort of the money issues come out, and with respect to adaptation strategies? It's a key question. Now, one of the ways that the city has sort of approached this question is through, over the last several years, has developed an institutional infrastructure to approach the question of sea level rise and the broader question of climate change adaptation. And basically, it sort of has an architecture somewhat similar to this. Through the mayor's office, we have the creation of a sustainability office, which is the Office of Long-Term Planning and Sustainability, which is then ushered forward two sort of separate but interlinked entities. One is a climate change stakeholder task force, which includes a lot of city agencies, as well as historically other sort of large private entities that deal with a lot of the critical infrastructure for the city, such as communications and transportation. And then an expert panel, which are providing information to the decision makers with respect to understanding what are some of the climate risks that the city are facing. And that's really the role of the NPCC, the New York City Panel on Climate Change. And what we've done historically is provided a lot of climate risk information, as well as sort of baseline information about adaptation opportunities, and sort of understanding of how to adjust existing climate risk protection levels for future climate change. Now, at the moment, there's a lot of discussion going on as to how to sort of move forward. And I just want to sort of paint this picture that as we sort of think about this issue of increased resilience and sort of rebuilding to Sandy, there's a lot of discussion, and there's a broad set of different sort of approaches that are being put forward. And I don't want to take up a lot of time. A lot of time here, but there are a range of different types of strategies that are being sort of put forward, and the policy discussion is really still very much underway at all levels as to how to move forward. Typically, the standard line is that it's best to have an integrated approach with a lot of different sort of opportunities. So, for example, that hard infrastructure, sort of building the seawalls and other kinds of things are certainly, been discussed. There's a tremendous amount of discussion about soft infrastructure, ecosystem services. We heard about the role of wetlands as protection, and there are a range of other sort of opportunities that are being put forward. And then, of course, there's a large scale policy shifts, increased zoning potential restrictions, and of course, there's in that discourse this idea: should we retreat from the coast? Should we be moving back from the coast? So there's a lot of different options that are out there, and maybe we can get into that in some of the discussion. So one of the things that's been particularly sort of progressive with respect to the city's action in December, the mayor put forward this idea of a special initiative on rebuilding and resilience, and it was sort of charged with several different questions to sort of understand, to create a more resilient New York in the wake of Hurricane Sandy, with the idea of how to rebuild and how to improve city infrastructure and the resilience of that infrastructure moving forward. And so the city is in the process of developing this report to try to sort of look at these critical questions. What happened during Sandy? What were some of the physical science questions that were sort of raised? What was the sort of the risk to New York moving forward with respect to climate risks and future extreme events, and how particularly to sort of address some of the issues that are being played out every day and still in some of the high-risk communities in Staten Island and some of the other boroughs of the city of New York. Now, there's been a range of different sort of issues that have come up, and this is maybe too small to sort of to see, but obviously one of the things I think, as a kind of observer of the process, one of the things that sort of became very clear as the New York could respond was this notion of having a lot of very effective climate baseline data that was available to sort of move from. And so the earlier report of the NPCC became an important sort of vehicle for action. Also, this notion of sort of rapid assessment. We saw some of the work that Frank and others have done sort of assessing what the damage was and sort of doing the inventories became very powerful. The idea of a long-term goal, sort of idea of promoting resilience as a sort of a rallying point has become, I think, an important element of this process. Interagency cooperation. So for some of the first time, we've seen a lot of interaction between city officials, state officials, as well as federal agencies, and trying to sort of coordinate the activity to promote a more comprehensive assessment process. The idea of sort of developing new risk and hazard metrics, I think, has also become, an important part of the discussion. And also with that, a set of new climate protection levels. How can we sort of, again, remember that cities were built with the idea of protecting residents and property from extreme events. And there's a lot of, code standards and regulations that are at place. So the idea is, how do we update those in the context of future climate change? Looking at this process with respect to a system and system sort of analogies as well as system analysis, I think has become very helpful in sort of motivating sort of action, as well as understanding where some of the particular stress points might be. Better understanding some of the climate science, the uncertainties, and some of the cost issues, I think, is another underlying question that still is being played out. And I think one of the last point here is the idea that we need to look at these events as learning opportunities, where that every event with climate change is we're not sort of looking backward as much or looking to the historical past, but we have to sort of understand what each event means to us and how we can embed this in this larger narrative of responding to a dynamic climate situation. And in turn, we also need to develop a more dynamic policy arena. And that's that notion of learning from each event and sort of using them as opportunities to sort of bring forward progressive new policies. And so I'll end with that, and sort of circling back to Staten Island for a moment. A colleague, Franco Montalto, took this photo, heavily impacted community, and the idea that Sandy and the interplay between climate change has begun this discussion. Katrina, in some ways, was a missed opportunity of linking climate change into disaster risk reduction. I'm much more hopeful at the moment that Sandy will afford us that opportunity, but I think these issues are still being played out. And I'll turn it back to Bill.
Thank you. Okay, I think we've heard from a storm surge perspective, climate change, city planning. You know, I'm a geologist, so I believe in looking to the past, and of course we know that if we look at the past, if you look on the left up here is a mapping that was done in 1880s on Staten Island. Map was published around 1900, and it shows that most of the shoreline of Staten Island was basically marshes, wetlands, tidal channels, dune fields, barrier islands, and you know, a lot of the area that was most impacted by Sandy was probably below sea level in 1880. So sea level is a foot higher, but the difference is you know, we went in and hardscaped and built in that particular area. And you know, if you look on the far right, where Allan, who's in the audience here, has done mapping of the most intense damage of the homes, you can see that the underprint of those tidal channels from the 1880s are still there, so that even within the marsh area that has been paved over, the worst damage was in the old tidal channels. And so I think what we need to do is to look both backwards and forwards to try to avoid some of the mistakes of the past. I've been offering what I call a 5-point plan, and I think everything we've talked about today fits into that. We need to protect our dune fields and marshes and wetlands and barrier islands wherever possible, because that's the natural system that protects the shoreline. Many coastal communities are in the process of rebuilding dune fields, reclaiming the marshes. Rezoning is always a tough conversation, especially in a densely populated area like metropolitan New York, but I know Bill mentioned rezoning is one of the things that we have to look like. I think, you know, the governor you know, put it when he said, when Mother Nature comes, you know, owns some of these parcels of land. And it's hard to argue with that, especially when we look at for the future. We need to consider engineering solutions in our particular area to protect us, and then education. I think we often forget the education piece of, you know, how do we keep people safe? How do we, you know, avoid the loss of life? I think with the proper education, there was no need for a lot of the loss of life that we saw as a result of this storm. The middle slide, especially if you look at the red, which is the highest topography in the area, we're not New Orleans, we're not the Netherlands. You know, areas that you might have to go several hundred miles inland to find high ground. We have a lot of high ground in metropolitan New York, and if we need to use that to our advantage in our planning, that, you know, we don't have to retreat as far as many coastal communities in the world would have to retreat in the face of a rising sea level. And I'm going to have one concluding slide at the very end, but I want to open it up now for questions from the audience, questions from the panelists, from each other, to see if we can turn this into more of a dialogue. I know there was one question to begin a minute ago from the front, but yes. Could you go to the microphone? Oh,
let me get my notes. You said that look at the events as a form or an opportunity of learning. What did we learn that we apply from Katrina and what happened in Katrina? And if there's just me talking like baseball and basketball is the same thing, it's not the same thing, but it's a disaster situation. What did we learn from Katrina that we apply on Sandy? I think we did learn something.
So, if I hear your question correctly, I mean, so what did we learn from Katrina that we actually integrated into the response to Sandy? Well, I think unfortunately, a lot of cases there was a lack of, a couple things. One is the interagency cooperation. I think certainly for Katrina, there really, you know, obviously there was a lot of failure, you know, bureaucratic failure at the federal level, but sort of connecting and sort of creating that sort of interplay between, you know, different entities within various levels of government, I think is something that they recognize. Now, disaster folks understand that. I mean, that's certainly part of the long-term history of disaster response. In Katrina context, some of those connection points weren't well made. And they recognized, particularly FEMA recognized that it needed to do a better job. But even like other things, like keeping folks in houses, in homes, and creating opportunities to sort of rapidly provide connection to community and keep people in place. Katrina was, there's, again, a lot of sociological literature about some of the longest lasting impacts of disasters is dislocation and sort of loss of sense of community, and either having the town, your community severely affected, you can't live there, or your sort of other aspects of the community are sort of collapsed. So in Katrina, unfortunately, it was sort of a large scale example where people were, under a variety of contexts, taken hundreds of miles away. And so that sense of loss of community then sort of became the sort of lingering aftermath. In Sandy, there's been a very conscious effort. Now, there's, all the elements are not perfect, but there's been a very conscious effort to keep people in place within their homes as much as possible, or if they're being housed within community or nearby. So that the idea of maintaining social networks, and that are so vital to the long-term recovery process. So that was another lesson. So two different scales of response, I would say.
Okay, thank you. I think I'll go one more from audience right, and then I'll come back to this microphone and then switch.
Thank you, Professor Solecki. You mentioned that there appears to be evidence that the city is integrating the evidence of future extreme possibility, the risk of future extreme events in its decisions to build in the building process. Now, homeowners, especially in Western Queens, are now facing issues where the insurance companies recognize the risk and the vulnerability, and they're jacking up those insurance rates. But I'm not so sure the city is really aware of it, because if you take a look at city planning hearings on the development of Western Queens, and go up to Willets Point, these areas are extraordinarily vulnerable in the estuary areas, in the Hell's Gate area. Now, why do you think the city is seen to be blind or deaf to situations where the insurance companies are aware of what the risks are?
Well, I mean, I think the standard response, obviously, is that the insurance companies are really like the canary in the coal mine, in this process, because they're the ones who are, most closely looking at issues of risk and sort of year by year, and so they've been, very aggressively working, since actually the turning point was for the insurance industry was Hurricane Andrew in 1992. Following Andrew, they moved a lot of their insurance capacity out of the state of Florida. And what happened as a result is that many of the states had to sort of create their own pools, insurance pools, which have gone oftentimes to the deficit in major events. So the insurance companies have, following that pattern, are the ones who are most aggressive with this. I think the issues that are playing out within all sort of within all governments, both if it's the state of New Jersey, state of New York, the city of New York, even at the federal level, there's still a question as to exactly how to respond. And so, I can't speak for the city. I'm not, of the city, so to speak. But, there is clearly a recognition, across all those different government entities that that with climate change demands a greater sort of, dynamism and sort of flexibility in policy making that traditionally they haven't been really great at. So it's a tremendously challenging time. But again, how that eventually plays out, I think is going to be the legacy of Sandy.
Okay, thank you. Let's.
I guess this ironically follows upon the previous gentleman. We're in an epoch in which the concept of doing anything public is somewhat of an obscenity, that we don't have a joint interest. We have, at various levels, been looking at and studying these things for decades. WNYC this morning talked about a newly revealed Corps of Engineers study to create a barrier for the Rockaway Peninsula. That was done 5 decades ago, following upon a major storm that took place in the 50s. Even before that, what was then the newly created Public Development Corporation, now known as EDC, which was created by the city in the 50s to build and operate modern industrial parks, a job that it failed totally at. A study was done in College Point, in what's now known as the College Point Corporate Park, that surrounds what was then operating Flushing Airport by SOM, their engineering division, that determined that that site really should not be developed. The substrata was just couldn't support if you were going to do anything at the absolute periphery. And it was also being considered at one point in time to be part of Flushing Meadows Park, simply because of those geological things. And we had in the 70s studies that were done in the city planning department on restoration of all the landfills, certainly surrounding Jamaica Bay, and studies in the 80s on the waterfront, when a waterfront division was set up, on how you would, taking what was then called global warming in context and sea rise, how you would develop areas like the Rockaways. But that's not institutionalized, because dollar signs always appear there, which explains the Willits Point, which explains the proposals that literally came right after the storm for building high-rise developments on pilings in the Easton and Hudson rivers, and things like that. So I guess I'm cynical and would like some sort of comment if there's any chance of having thought and proper investment come before these simple so-called gains that seem to trump any sanity in where we do our investments and where we allow development.
Maybe before I turn it over to Bill, let me just jump in from maybe from the high-level perspective. I think that education is a big piece of it. I think educating people on how storm surge works, how vulnerable we are, the more people that we have educated about the very processes that we're talking about today, the more that's going to drive policymakers and public officials and decision makers into taking that data. So to me, that's the whole reason that we're having the forum today, is to begin that conversation. But Bill, do you want to offer any?
Well, I mean, certainly, the notion that we build in high-risk areas, that's sort of part of, unfortunately, the system in which we are present. Not only, whether it's earthquakes or, there's a lot of different sort of examples. And it's an interesting moment because, the city grew up around the water's edge. It sort of became a city because of the water's edge. The last 10, 20 years, there's a renaissance of the water's edge in terms of redevelopment, tremendous amount of residential redevelopment going on, old industrial lands, et cetera. You know the story. Just at the moment when we're starting to understand that these are not only areas that are at risk, but at increasing risk. So how do you balance that, that tension?
But the risk analysis, my point was already being pointed out before we began this large-scale redevelopment of the Williamsburg.
Absolutely. It's, but again, it's not unfortunately unique to this region. We can speak to lots of examples of that. It's true.
I'd suggest we have time for about one or two more quick questions, and I have one concluding slide.
Let me redirect this to another piece of the problem, to Frank. As we see that the Army Corps is redoing flood maps, and presumably flood insurance rates will change in light of our new flood maps, how is this likely to have any direct or indirect impact on our land use planning and rezoning in the areas that are vulnerable?
I imagine it will. As a matter of fact, the Army Corps has started a comprehensive plan for much of the eastern seaboard following Hurricane Sandy, which is about to take place starting in the next few weeks. They've already relocated some of Army Corps personnel to start looking at this comprehensive plan. How that will then tie into FEMA, that I can't really speak to. FEMA is sort of its own entity, has its own guidelines on flood mapping, right? They talk to each other a little bit, but in the end, FEMA is its own entity. But I can speaking from the Army Corps perspective, they are now looking at what to do with the entire eastern seaboard and their current methods of operation and the current plans that they build, their mitigation strategies. They're looking at all of these things now.
question on this side.
Yeah, hi there. I'm curious whether there are any other extreme weather events we ought to be looking at in addition to hurricanes. Not to minimize the hurricane issue, but are there other issues that we're not looking at with extreme weather events here in the metropolitan area?
Well, I think there are. I mean, you know, these big rain events and flooding, whether they're hurricanes or, you know, smaller than a hurricane, it could still be very problematic. And there's the flip side of it, droughts. You can actually have a changing climate when you can have a higher frequency of flooding events and more frequent droughts. And of course, heat waves, which are a big health hazard.
Thank you.
Maybe the final question on that.
Okay. I have a very detailed knowledge of New York City's weather history. I am quoted sometimes in the Times and other local papers as New York's unofficial weather historian. But I'll try to stick to a line that is peripheral but not irrelevant to what you guys have been discussing. And that is the state of the record keeping in regard to stormy weather at the National Weather Service. It's not quite as scandalous as what happened in Benghazi, but I think it might bear upon the public's interest in actually looking at some of these records that I would tell the audience and you guys a couple of very curious things, and I certainly want your opinion of it. In regard, not so much to Sandy as to Irene, if you looked at the National Weather Service records for the month of August 2011, which had the wettest month at Central Park on record, 18.95 inches, you will find a column of thunderstorms. And the total number of thunderstorms in this column, and also in the annual report for 2011, and all of the years since the Weather Service actually physically moved out of Manhattan to Brookhaven, Long Island, the total number of thunderstorms during that wettest of all months is listed as 0, as is the total for the year. It should be a blank, just, you know, and that would be fine. So that's a good example of somebody was keeping those records. They put in zeros instead of blanks when the Weather Service, they have a record for fog, as you know, on the radio and TV. Okay, so that's an interesting example of peculiar record keeping that should be corrected. I don't get paid for this, unfortunately, so I don't have the energy to take it up, but maybe you guys could do it. Now, on a related theme, the severity of severe weather in the form of snowstorms. Not always, but in the last 5, 10, I haven't quite pinned it down, years, when you look up the annual report of NOAA, which is published in every year's World Almanac. This World Almanac has the year 2011. Under the heading of precipitation, greatest precipitation in 24 hours, you will see the correct figure for the heaviest storm that occurred in that August of 2011. But when it comes to snowstorms, they've come up with a very curious wrinkle. They have a little thing at the bottom which says, if it's a storm of more than one day, we will just mention the first day. But what they don't tell you is as follows. January 26th to 27th, 2011, the snowiest of all Januaries, and one of the two big storms that month, they list the 26th of January, and it says 12.3 inches. They do not give the 24-hour figure, so that if you're looking at the severity of the weather, the 24-hour figure was 19.0 inches, but their little peculiar record keeping has wound up with this interesting diminution of actually how severe these storms are. And that goes for every place in the United States where that is one of the variables. And so that's something fine. Now on the lighter side, I know we all want to get the refreshments. I'm sure some of you are familiar with the problem of New York City Public Library wants to put a lot of books in New Jersey, not in a sandy, vulnerable area, but they want to change what they have in the main building. As of 5-6 years ago, a great source of information to me, and I hope a few other people, the bound volumes of the Central Park weather records, which I had used many times and gotten much information from, they all went off to New Jersey. Of all the ironic things that shouldn't be in New Jersey, I'm not anti-New Jersey, I think the Central Park weather records are pretty good, and I have now discovered that even the folder in the reference library down the block has disappeared from the shelf because the Weather Service stopped sending the monthly reports. You can only get them online in some fancy algorithm. And that, I hope, will be enough to enliven the...
All right, we're just about out of time, but Allan, do you want to respond to the importance of record keeping?
Well, it's maybe amusing to some people, but first of all, I'd like to talk to you and meet you afterwards, if that's okay. He actually touches on a good point, which is the data. Even though we're talking about looking into the future, you can't understand how the future is going to be different if you don't know what happened in the past. And worldwide, the number of meteorological stations increased up until about 20, 30 years ago, and then started decreasing and continues to decrease. Because government funding gets cut around the world, and
Locally as well.
and locally, just in general. And recently, a bunch of USGS stations around the New York City area were defunded, for example. And some of the justification for that is that we can use satellites to make up for that, and satellites give us a lot of information. Meteorological stations and stream gauge stations gives us a lot of information. None of that information is perfect, but in a time when we need to be studying these things in greater detail, the funding for the data, for certain types of data, is actually decreasing, and people in my business, this is a problem for us.
Okay, we're just about out of time. I really want to conclude. One of the pieces that I've been talking about is the importance of education, and I think it really touches on some of the questions that we have is how do we move forward as a city to plan for the future. And I think we need to educate people about climate change, about storm surges. We're not the only city in the world that's faced with a rising sea level. Many communities that are faced with whether they're tsunamis, which is a rush of water coming inland from an earthquake, or storm surges, which would be hurricane generated, have signage and things that I think helps impress on people in daily lives. I think in the New York area, if we had signage like the signs that I'm promoting behind us here, where green is safe, yellow or orange is unsafe areas. It doesn't mean that you don't build and you don't use the yellow or orange areas, but if you live in a yellow or orange area, you're aware of it. You know where. I've talked to many people whose family members lost their lives on Staten Island that said, I didn't know where to go, because I've said to the families, why didn't you get out? I think that we're taught to go in our basements for tornadoes, which works for a tornado, but in a storm surge, going into your basement is the worst possible thing that you can do. And so images like this that other coastal communities use that really impress that you climb to safety in a storm surge, these are low-cost solutions that keep on everybody's mind that we are living with a rising sea level, and we need to take steps to protect ourselves. The reason I added the car to the image on the left, on Staten Island, tens of thousands of people, not only did they lose their home, but they lost their automobiles. And in a borough that has fairly poor public transportation, losing your car means you have no ability to get to work. And so the economic impact of those lost cars, and I'm suggesting we have areas in city planning, like on the right, where you designate malls or parks or areas so that we people need to realize, move your car to high ground so that you don't, even if you can't move your home. And so I just want to end us with the thought that there are some simple things that we can do, focusing on the education piece, that I think will help drive that conversation moving forward. I really want to thank our other three panelists, and I'm sure that we'll have lots of time, over the break to continue the conversation. So thank you. I really appreciate it.